Welcome to the DFAB RhinoCAM2 tutorials. Today we're going to be explaining roughing. When you have geometry in Rhino, you need to understand a few things. We first need to figure out how big of a stock we're going to create to mill from. I have my geometry. I type in bounding box, and I select between world or CP plane. We're going to go with world. This shows a box containing all of my geometry. So now we can understand how tall my material stock is going to need to be. From here to here, it's 2.5 inches. Okay, so I'll take a few other glances. So this is a concern here. This corner goes all the way down to z equals 0, which is the CNC table surface. When you get that thin on the material, the bits tend to blow out the material there, meaning it rips the corner off and does not give you the clean geometry you're looking for. So we'll delete our bounding box, and you just move it up. Move it vertically. I like to do 1/4 inch. You can do 1/8 of an inch, but I prefer 1/4. So that's up. We need to again get our box, but now that our surface is above z equals 0, we'll select our line work, which this line work is the final cut dimension of my surface that I'm creating here, which is going to be a drawer face. I want to select that and my surface. We'll type in bounding box again world. This gives me the distance of 2.75. So I need to create a material stock 2.75. I'll write that down. The other step is to place the bottom left corner in top view and the very bottom corner here at the origin, so 0, 0, 0. The machine needs to understand where your material is as well as you need to understand, so when the machine starts milling, it understands where your material is and you can place it in the correct location. The next step is to start to create our RhinoCam. So we will select our bounding box. You're going to start in setup. I'm going to select here on stock. I'm going to go to box stock and copy model bounding box. This is going to take the information from that bounding box and create a box stock. And then I will hide my bounding box. And you can see it still shows that. This allows Rhino to understand what's being milled. You can leave that on. I prefer to turn it off. You can do that here on stock visibility. The next step, I'm going to select my surface, go over to create. I'm going to go down to the 3-axis button. I'm going to do the drop down, go to horizontal run. I'm going to go to tools. I'm going to select my 1/2 inch square end mill for roughing. Feeds and speeds. For spindle speed, we range between 18,000 and 20,000 RPMs. I'm going to be cutting MDF, so I like to run the bit a little faster there. For plywoods, 20,000 is a good speed, but it just depends. If you have a preference, you can kind of explore this. Your plunge, your approach, your engage, retract, and departure are all always going to be 50. Your cut feed is the important one here. This is the number that will vary. All these will always be 50 other than the cut feed. So the cut feed ranges between 200 and 300. 200 is a good plywood speed. It gives a clean edge. 300 is a good MDF speed. It just depends on the material you're cutting and the density. So we're going to run it at 300 and 20,000 RPMs and everything else at 50. The clearance plane, this is the travel of the bit when not engaged in the material. So when it's not cutting and when it's going to its cut location. We always use absolute Z. It'll start out on automatic. So click on absolute Z value. And that is the material thickness plus 1/2 inch, which is 2.75 plus 1/2 inch, which will be 3.25. Next, for cut transfer method, will be clearance plane. There's a skim plane option. That's used for parallel finishing. but for roughing we use clearance plane. In case of any discrepancies in the material height or bowing of the material, we keep on clearance plane, therefore it allows the bit to run higher off the material in case it's bowed, and it won't cut your material where you don't want it to. Next we go to cut parameters. The first two will be 0.001, both of those, and then your stock will be 0. This is the accuracy of the machine in relation to the accuracy of your geometry in the file. I like to keep it as accurate as I can. So the next is cut pattern. There's 3 different options. I prefer to use pocketing. For roughing, it's faster, but each one gives you a different effect of the tool. So it gives you a different tooling material effect. You can play with it, but I prefer to do pocketing. Cut directions, mixed. The important one here is step over control. That says how much the bit is going to step over into its next cut length. It's a percentage, so we try to stay at 50, no more above 50%. MDF you can run a little bit higher, but plywoods you want to do no more than 50. It just keeps down on wear on the bits, keeps the bit sharper and your cuts cleaner. So the 50 there. Cut levels, we have the step down control. This is the same thing as the step over, except in the Z direction. Again, I'm going to keep that at 50. Engage and retract. These are going to be 0. These are always going to be 0, other than if you're cutting aluminum. It eases into the cut and allows more delicate materials such as aluminum, because it's a soft material, to have cleaner cuts. Advanced cut parameters you're not going to need to worry about. We'll generate that, and it's going to compute the tool paths, and it's going to show cyan lines showing where the tool is engaged in the material and cutting, and there's going to be red lines. That will be where the tool is traveling, the bit is traveling across the material, not engaged. So you can see these red lines here is where the bit will lift up and travel over to its next cut area. The blue lines are the area that's actually getting cut. I like to double check everything. It's always a good thing. 1/2 inch square. Feeds and speeds look good. Clearance plane, correct numbers. Parameters. These are all what we discussed. So you can double check these. The next step is to go to simulate, excuse me. And the box stock is shown. So once we simulate, it's going to show what CNC is going to do and the procedure it's going to go through to cut your material. As you can see, it's showing the blue lines of where it's cutting and hogging away the material. The red line is the travel of the bit above the material. This is a good place to look for errors. If there's any errors, it will show a large red plane or a surface where the bit is obstructed by the material. This is a clean geometry and we look good to go. So that is roughing.